Okay, now we will do example 512. The title of this example is Economic Desirability of a Project Using the IRR Method. AMT Incorporated is considering the purchase of a digital camera for the maintenance of design specifications by feeding digital pictures directly into an engineering workstation where computer-aided design files can be superimposed over the digital pictures. Differences between the two images can be noted, and corrections as appropriate can then be made by design engineers. The capital investment requirement is $345,000, and the estimated market value of the system after a 6-year study period is $115,000. Annual revenues attributable to the new camera system will be $120,000, whereas additional annual expenses will be $22,000. You have been asked by management to determine the IRR of this project and to make a recommendation. The corporation's MAR is 20% per year. Solve first by using the linear interpolation and then by using a spreadsheet. Okay, now here we are going to first solve this problem by using the linear interpolation method. Linear interpolation method is used to solve the IRR problems. In this example, we can easily see that the sum of positive cash flows, the total sum is $835,000. This value exceeds the sum of negative cash flows, which is $455,000. Therefore, it is likely that a positive valued IRR can be determined. So we can predict a positive valued IRR. By writing an equation for the present worth of the project's total net cash flow and setting it equal to 0, we can compute the IRR. Here in this formula, we have the present worth equal to 0. Why? Because to find out the IRR value, we set the present worth equal to 0, and the interest rate that makes present worth equal to 0 is IRR. The first thing we have is the negative $345,000, which is the initial investment required. And $120,000 is our annual revenues coming from this new camera system. And $22,000 is our annual expenses. These values are annuities. One of them is annual revenues and the other one is the annual expenses. And the difference between them is our net annual revenue. And this value should be converted from annuity to present by using this factor, P given A factor, for the unknown interest rate. This interest rate is unknown, and for 6 years. Okay, actually, this interest rate is going to be our IRR. The question is, what is IRR? And finally, we also have $115,000, which is our market value at the end of 6-year study period. So this is our market value. Since it's at the end of the study period, it is a future value, and therefore it has to be converted from future to present, and again with the unknown interest rate IRR, and for 6 years. To use the linear interpolation, we first need to try a few values for I. A good starting point is generally MAR itself. Since the MAR is given to be 20%, then we will first try 20% of interest value. We put this 20% into place into the formula, and we get the present worth of the total cash flows is $19,413. Since this present worth value is positive, at the 20% interest rate, we know that the interest rate we are looking for should be greater than 20%. So now let's continue with the problem. And then since we know that the interest rate should be greater than 20%, let's try 25%. Again, we put all the numbers in place, but this time we use 25% as the interest rate. And now we get a negative value of present worth, which is negative $25,621. Now that we have both a positive and a negative present worth value, this is what we want in the interpolation method. We just need a positive and negative present worth value because we are looking for the value of 0. We did some examples before in chapter 4, you remember this interpolation method. And the answer is bracketed in between 20% and 25%. The dashed curve in the figure 5.5, let me show you that figure here. Yes, in this figure, we are looking for a value in between 20% and 25. And now here we are applying a linear interpolation method. And the interest rate we are looking for should be somewhere here. And here, the value corresponding to the present worth value corresponding to 20% is $19,413. And the value corresponding to 25% is a negative $25,621. Now we draw a triangle here, this triangle, ABC triangle. And this larger triangle is similar to ADE triangle here. And we know that from the similarity of triangles, triangle ABC and ADE are similar in terms of their angles, and therefore we can use the ratio analysis here. As you know that this AD divided by AB is going to be equal to the ratio of the DE divided by BC, and so on. So all the ratios of the triangle should be equal to each other. Let's go back to the previous slide. Therefore, we can write here that line BA divided by line BC is equal to line DA divided by line DE. Here, BA is the line segment B minus A, which is 25% minus 20%. We put the numbers into the formula, the ratios of the formulas. And here, the only unknown value is this interest rate, which is IRR. And from here, if we do the calculations, the IRR, the interest rate, is approximately equal to 22.16%. Because the IRR of the project, which is 22.16%, is greater than MAR. Remember, MAR was 20%. Since this IRR is greater than MAR, we say that the project is acceptable. And this was the hand solution by using the interpolation method. Now we do a spreadsheet solution. The figure that I will show you in a minute displays the spreadsheet solution for this example. Let me show you that spreadsheet. It's here. Here again, let me open the pen here. Okay, we put all the data here. Our MAR is 20%. Our initial investment is $345,000. Annual market value is $115,000. $120,000 annual revenues, $22,000 annual expenses, and the study period is 6 years. Now, we have to put all the data into this specific format because Excel can understand the data in this way. The cash flow should be like this, and the end of years, number of years, and the cash flows should appear here. As I told you before, numbers in parentheses in the old versions of Excel is in negative values. There's one thing here. since there are two number of years 6 here, we also have to make a conversion from this to this, because number of year 6 should only be 1. Therefore, we combine these two together and we put it as $213,000. Now we have a specific format for Excel. At the bottom, we can now calculate the internal rate of return we are looking for. Who is calculating this value? This function. This function here is calculating. The IRR function of Microsoft Excel is used to calculate the internal rate of return value, which is giving us 22.0%. We have to specify the specific range E9 to E15, which is E9 here, which is starting from here, to E15 up to here. This is the range. And B1 value is coming from this MAR value here. And we can make our IRR calculation here by using this IRR function in Excel.